In Chapter 4, we talked about the area formula for a segment. And the area of a segment was given as m over 360 times pi r squared. It's based on taking a sector's area and then removing a triangle from it. So 1/2 base times height. And so basically, when you're looking at this figure, you would take the entire sector, which is the entire shaded region, and then you're going to remove this triangular region right here from it. When you remove that, you're left with just your segment. Okay, so there's the area formula for a segment. Okay, if I gave you the following pieces of information, I want you to see if you can find this area. Okay, let's say the central angle that contains the segment is 110 degrees. And let's say the circumference of this whole circle is 12 pi. And I'll give you units of centimeters. I want you to see how far you can get in the next couple minutes of finding the area of this segment, please. All right, let's say we start with our equation, just like I would suggest at any time that you're working through these problems. And let's fill in the information we know. Do we know what our m value is? The arc measure is that central angle measure. So we have 110 over 360 times pi r squared. Can we determine what our radius is? Well, since our circumference, which is designated as d pi, is equal to 12 pi, we know that our diameter is 12. If the diameter is 12, the radius is going to be 6. So we have a radius of 6 minus 1/2 our base and our height. Okay, so are 6 and 6 our base and height here? No. In order for those to be our base and height, what would that central angle have to be? 90. If it was 90 degrees, then those are going to be our base and our height. In this case, it's not. So what we have to do is we have to use a different set of base and height. It's not just going to be those. Okay, if these sides, if the radii don't form the base and the height, then it's very likely what you're going to be looking at is a base of this chord and then a height from that chord to the center of the circle. Okay, so if we look at this example right here, so I'm just going to redraw this picture. Okay, if I use this as my height and my base would then be this whole length from here to here. Okay. When I draw this altitude, or what specific type of triangle is formed in here when we remove the triangle from a segment? Each of the sides is equal. It's a radius of the circle. Therefore, you're dealing with an isosceles triangle, right? And so when you draw your altitude to the base of an isosceles triangle, what does that altitude do to the base? Cuts it in half, right, or bisects it. So you know that these two segments of B, the whole base, are the same. So let's call it x. If I call that x and my height h, I know that this hypotenuse now of the triangle, the right triangle that I form in there, was a 6. And do I know any other information about that triangle? What's this angle going to be right here? It's half of 110 or 55. So I know that angle as well. So now do I have enough information to create expressions for the height and the base? Yeah. If we look at the height we can find by using as a reference this angle measure. We have the adjacent side, and we have the hypotenuse, so which trig ratio relates adjacent hypotenuse? cosine. So we can set up the ratio cosine of 55 is equal to adjacent h over hypotenuse 6. And we can solve this by multiplying both sides by 6. So here's our height. We can substitute in 6 times the cosine of 55. The last thing we need to do is find our base. And so if we use, again, our angle of 55, we have our opposite side. We also have a hypotenuse. The trig ratio that relates opposite and hypotenuse is sine. So we have the ratio, the sine ratio of 55 degrees is equal to x over 6. So we can solve for x by multiplying both sides by 6 once again. Okay, and so 6 times the sine of 55 is x, but now what was x? X is half of b, so what do we need to multiply that by? 2, right? We need to have 2 of those x's. So again, I'm showing you leaving all the calculations in place. You could either just cancel the half if you want. You can multiply the 6 and the 2 here. But here is your calculation. And so now when you use your calculator and just go through that calculation. So 110 divided by 360 times pi times 6 squared minus 1/2 times 2 times 6 times the sine of 55, all times 6 times the cosine of 55. Again, all I've done is copied down my entire calculation. Okay. I do want my answer to be in decimal form, and I haven't entered a decimal. So once again, I'm going to hit the green diamond button, and this gives me my area. My area for that segment is about 17.64. The units are centimeters. It's an area, so it's two-dimensional. And so that would be my solution. Yeah, there. Why this is a 2? Because when I found my x value is just this piece, yeah, it's half of that base, so I have to double it to get the whole base b. All right, other questions on that?